Hi everyone. So I'm assuming that you guys are watching this video because you guys watched the other part first. Okay. If you haven't watched the other part yet, I would highly recommend you to watch that part first, because this video basically starts from where we finished in the other video. Okay. So maybe it'll make more sense if you watch the other part first and then come back and watch this one. Okay? Well, so in the other part, okay, we were trying to compare the crowdedness of pool A and pool B by figuring out how much personal space each person would have, or each person would get, if the total area of each of the two pools were divided equally, okay, amongst the people in that swimming pool. Okay, so for pool A, we found out that, if 30 square meters, which is the total area of swimming pool A, was divided by 20 people, each person will have a personal space or a personal area of 1.5 square meters. Okay? And for pool B, we found out that each person will be given a personal area of 1.4 square meters. Okay? And we used those numbers to compare the crowdedness of the two swimming pools, and our conclusion was, well, pool B is more crowded because, okay, each of the 34 people will have 0.1 square meters less than the people in pool A. Okay, now in this video I would like to talk about another way we can go about comparing the crowdedness of the two swimming pools. Okay, so I'm going to change the screen here. Okay, we're still using the same, information or data, I guess, about the two swimming pools. Okay, so pool A has 20 people, and I think we found out that the area of swimming pool A is 30 square meters, and the area of swimming pool B is 48 square meters. Now, this time, instead of figuring out how much, personal space or area each person in each of the two swimming pools will be getting, equally, okay, we're going to, why don't we figure out how many people there will be in each square meters, okay, in each square meter, if the same amount of people were, placed or positioned, okay, per each square meter. Now, how do we find out? How do we find that out? Okay. Well, maybe the number sentence we can use to solve that for pool A is this here. Why don't we divide, okay, 20 people, which is the total number of people in pool A, why don't we divide that by 30 square meters, which is the total area. Okay? And if we do that, we should be able to figure out, right, how many people there will be in each square meters. Okay? So I'm going to take out my calculator again. Okay, and I'm going to do 20 divided by 30, and that's going to give me, okay, 0.66666. It's basically going to be repeated forever, and that's why the calculator just rounded this number to 7, because 6 is just basically continuing forever. Okay, so why don't I maybe round this decimal number to the nearest tenth place, okay, and that will give me 0.7. Now 0.7 what? Last time, right, I guess the unit was square meters. But is that the unit we're going to be using again this time? And the answer is no, because look, the number sentence is slightly different, right? This time we're doing 20 people divided by 30 square meters. Okay? So we're dividing, 20 people. Okay? So the unit we should be using for the answer is people, right? Okay, because we started with people. Okay, so it's 0.7 people, but we're not done yet, right? What exactly does 0.7 mean? It means that's the number of people for each square meter, right? Because we divided 20 people into 30 square meters. Okay, so 0.7 is the number of people. Maybe instead of for each, I can change it again to per square meter. Okay, so if we divide the total number of people in pool A by the area, there will be 0.7 people in each square meter. Okay, I know this is a little bit hard to imagine because, well, simply, can we have 0.7 people? Well, the answer is no. But again, when we're talking about, when we're talking about this, we're kind of imagining that if the same amount of people were placed in every square meter, then there's going to be 0.7 people, because we can't place one person per every square meter, right? Because we don't have enough people to place one person for each of the 30 square meters. Because if we place one person for each square meter, we need 30 people, because there's the area is 30 square meters. We have less than 30, so again, if we're imagining that we place the equal number of people per each square meter, it's going to be less than 1, in this case 0.7. Okay. Now, let's figure out how many people per square meter for pool B. Okay. And I think the number sentence that we can use to solve that is 34 people divided by 48 square meters. Okay, and if we do that using our calculator, okay, 34 divided by 48, that'll give us this number. Alright, now again, just like we did for the other calculation, let's round this number to the nearest 10th place as well. And if we do that, we will get 0.7 what? 0.7 people per square meter. So for pool B, there is going to be 0.7 people for every square meter if we divide the number of people equally into each square meters. Now, we have a bit of a problem here now. Okay, again, our goal is to compare the crowdedness of pool A and pool B and figure out which is more crowded, right? But if we look at the number of people per square meter for each of the two swimming pools, it's the same. It's the same. So does that mean, the crowdedness of each pool is the same? Now, when we try to, compare the crowdedness and figure out which is more crowded using the other way in the previous video, by, finding out how much area each person will get if the total area was divided by the number of people, okay, we came to the conclusion that pool B was more crowded, right? Well, but if we, this time, when we try to find out how much or how many people there will be in each square meter, we're seeing that, you know, it's going to be the same amount of people. But is that true? Does that make sense? Okay. Now, the reason this happened, the reason this problem happened is because we rounded these numbers to the nearest 10th place. Let's solve the number sentence again using the calculator, and this time let's pay a little bit more attention to the number, you know, the actual number, okay? Not the number that we round to, but the actual number. Okay, so let me do 20 divided by 30 again, because that's the number sentence here. Okay, so 20 divided by 30 equals, alright, when we round it to the nearest tenths, we said 0.7, but the actual number is less than 0.7, right? It's less than that. Okay, how about this one? Okay, how about this side? Okay, so the number sentence is 34 divided by 48. So 34 divided by 48. And that gives us we rounded it to 0.7, but it's actually a little bit more. So the actual number of people, okay, when we compare the actual number of people, pool B seems to have a little bit more people for every square meter if the number of people was divided equally into each square meters. Okay, so what does that mean then? If there are more people, okay, per each square meter with pool B, doesn't that mean that pool B will be more crowded because there's more people in an area that is 1 square meters? So again, okay, by trying it this way, by trying to find out how many people there will be per square meter for each swimming pool, we end up, you know, finding out that pool B is more crowded than pool A, right? So I guess the message here is, I guess the point I'm trying to make here is, there's, you know, by now, okay, after watching this video and then the other part of this video, okay, I think you guys were exposed, you guys were introduced or explained basically 2 different ways to go about, you know, comparing the crowdedness of 2 or more places. Okay, now it shouldn't really matter which way you use. And I think I was able to prove that. It shouldn't matter. Okay? Or not shouldn't. It will not matter. Okay? So, alright. I hope that, you know, after watching the 2 parts of the video, you were able to kind of understand, you know, one, how we can compare the crowdedness of 2 or more places, and through that process decide, you know, which place or area is more crowded. Alright? Well, thank you very much for watching this video. Again, I really hope that these videos helped you. If you have any questions, please feel free to ask me anytime, and I will be more than happy to answer your questions and, you know, work together with you to help you understand, you know, the things we covered in the 2 videos together. Okay? Well, again, thank you for listening, or sorry, watching. Bye-bye.